Next up, we have Franklin Cook with the Executable Books Project and with CurveNote. He's going to talk about executable, reproducible scientific computations for publishing. So thanks very much.
I'm Franklin, and Rowan wasn't going to give this talk, but he is sick, so he can come. We've been working together for a long time at CurveNote, and yeah, with executable books. I've been working a lot on the MyST project, and what we're really trying to do is make scientific publishing just modern and much, much better than it currently is. Cool. So I just want to start out thinking about science communication today. And this isn't what most of the talks are about here. I think there's a ton of talks here about these awesome Jupyter workflows and interactivity and working together and reproducibility and sharing and collaboration. And that's all really good. The problem is, though, science, when you get to the end of it and you're actually having something that you're finished with and you're presenting to the world as like an artifact to exist forever, it still is this PDF, which is really unfortunate. And I mean, like, even when I was giving this talk, Chris joked, and he's like, oh, well, where's your USB with your slides on it? And I was like, oh, that doesn't make any sense. That's from like 10 years ago or 15 years ago that I need a USB with my slides on it. But the paper, it's like, okay, well, I could be talking to Newton about my paper, and he'd understand the format. And so this, like, it doesn't have any data associated with it or code. And of course, there's no interactivity in the PDF. You can't execute anything in there. I think some of the best journals have supplemental material, and you can access data and notebooks. But that's about as good as it gets here at the final stages. It's also really hard to navigate. Like if you're in your paper and it says figure 3, you have to scroll and find figure 3 and scroll back to where you were. You have a citation that says some last name, you have to scroll all the way to the bottom, figure out who it was, scroll all the way back up. And then if it's like, oh, see figure 3 in this other paper, now you're off to Google Scholar to get a new PDF to find the figure and scroll all around. And it just is, you're losing so much time that you could be learning and doing better science. And then it's also still trying to emulate paper. So there's no thought about being on the web or being mobile friendly with all these students who are standing in line at Starbucks trying to read papers desperately. They're just like zooming in on their real PDF and scrolling around and not interacting with anything. It just feels really bad, I think. And it could be so much better. So that's what we're trying to do with MyST, is make this final way that science is communicated and published so much better. So just a few kind of big things. What if, like in a paper, when you had footnotes or citations or links to figures, you could just click and see them directly in line, in context. They could pop up, even have little interactive bits that pop up, and you don't have to navigate around. Those could even link to figures in other papers. Having computation inline, I think this is a pretty familiar thing at this conference, but this is like, why can't this come with the final paper? Why can't this be how papers are published, that you have a little button, you push a button, and all of a sudden your paper is running and people can play with your figures? And then the last thing I have here is what if your paper could be connected to sort of the environment that you're creating your research in? And so this example is taking variables from your code and putting them right in your paper. So you can kind of even rethink what your paper content looks like, and you can have widgets and have it be interactive and let people sort of explore your research in a way that is more how you think about your research and how you did your research, and just a different way that totally breaks the paradigm of being a static piece of paper. And then, of course, we still want to be able to export these static outputs because people still want a PDF that they can print and look at. But maybe it doesn't matter anymore what the PDF is, and we can just export it to Word or any various template. And at the same time, take the same source that you were writing and make an interactive website or journal that has all the features that we were just looking at. Cool. So that's what we're doing with MyST. We're trying to do that and so much more, and have MyST be the way that publications are. So MyST is a few different things. first of all, it's a markup language, so this is like the way of writing. This is, it extends Common Mark, and it's inspired by restructured text with some features that are just catered towards scientific authors and people who are working in computational environments. It's also an underlying specification, so that's like the structured data of your document. So you can write in your markup language, but then fundamentally that gets parsed into this structured data that you can then reuse. And that's where these other exports come from, is you have this source, this well-defined structured data that you can then export to different PDFs or Word documents or websites. And then MyST is also some of the tooling around it, so command line tools that let you get started and build your websites and make exports. And this is all, one thing that's important to us is to be part of a community and be an open source project, and so we're part of the Executable Books project. That's, yeah, kind of working alongside JupyterBook and building MyST from there. So I think most of this talk, I'm just gonna kind of go through and demo some things. Yeah, so where I'm starting here, I'm hoping this is like a kind of familiar workspace to be in. So we have a paper, which we've written in Markdown, and then a folder that's just a bunch of notebooks. We have some Python scripts and some other license information, a table of contents. This just kind of shows what's there, the paper and the notebooks. And then like that, if you're on GitHub, you probably have a README as well. Cool. So then, yeah, to get started with MyST, if you're in an environment that looks kind of like this, you can just MyST init. And so this is initiating a MyST YAML. So this is like metadata configuration. And it's saying, do you want to start your MyST site now? And we can do that. It downloads a web template. So this is like the JavaScript that is around the content that you're feeding into it. It takes a little bit to do that. It builds the content of your website, and then you have your website up here, which has all of the content from your paper over here. This is kind of cramped. I'll probably not keep it this cramped, but anyway. And so this is your paper with your notebooks here, and each of these notebooks has their own page. Which is, so some good stuff, and is pretty easy to do, I guess. Assuming you have your environment set up like that, you can just get started immediately and have a nice website like this. But we can make some improvements here and add some things. I think one thing that I wanted to do, I should point out that in JupyterLab here, we're running a MyST extension. And so these cells here, they're not just normal Jupyter Markdown cells, they're MyST Markdown cells, which means we have a few little features, like we can turn these into task lists, which I don't think is in standard Markdown. That's a tiny little thing that happens there. We can hop over to this page on the website and see where it was. I think it was this one. Oh, man. Oh yeah, we have to save this. And so this is all building. This is all building in real time. So we saved our content here and it updated the website. This is just like little things. We can turn this into a admonition. We can say info. And gotta finish it. That didn't work. I don't know if that's messing it up. That's not messing it up. Note, perfect. Love it. Wonderful. Thank you. Anyway, so that, and then when we save it, that goes over here. I don't know, this is like, this is kind of the basic MyST Markdown. Cool. So then what other more interesting things can we do? I think we can start adding some front matter, so let's take a look at our MyST YAML. Maybe we want to add some licenses. Can start out with just like a MIT license and save that. And so that'll get info about the license there at the top. That's added to every page since it's on the project. You can give your code and your content, separate licenses, and there's, yeah, like CC by SA, and there's some like validation here, so I think this one's maybe an invalid, maybe slightly invalid. Well, maybe that's okay. Let's make it definitely invalid. Let's make it 5. How's that? Oh, that's still okay. That was all good. No, it's just totally ignoring it's ignoring the key. I should have practiced this demo more, but that's fine. There we go, cool. So now there's also some validation here in saying, okay, well, this isn't a valid license because there's no Creative Commons 5 yet. So we can fix that to like 3.0. Yeah, good stuff. And now it's happy again, and we have our little CC over here, our different license things, a link to our MIT license for the code. Nice. So I don't know, I have some little cheating metadata over here, so we can add like title and a subtitle, and put that over here. These guys. None of this is super interesting, I don't think, but just little bits of metadata that update your site and give you little icons over here. Cool. Let's maybe move on to some more interesting things. Oh, I guess maybe we should give some authors too. That's probably worthwhile. And so this is just copying in some authors to our MyST YAML. Good stuff. And those go. Maybe show up. Cool. I totally broke it. That's awesome. But that's totally fine, because that's just like tabs and stuff, which is really fun. Huh? Nice. Okay. Perfect. Look at that. Anyway, and then we can start this again. Cool. Now you have your authors, your affiliations. If you make it full screen, it'll probably look better. Cool. And then, I don't know, we can give that page a title, because that page doesn't have a title, which is looking a little bit strange. So we can also do front matter here on the pages themselves, and so we can give this a title and say pixels and their neighbors. Nice, looking better. All right, cool. So what else can we do that's a little bit more interesting and more like the GIFs in the other part? Citations. Let's add a new citation. So I'm gonna add a citation that isn't right at all, but that's okay. This is just for some paper here that I wrote forever ago. So we can grab the DOI and put that in here, and we can just link to it. So this is one sort of nice thing about MyST, is that links to interesting stuff can just be done like sort of normal, easy to understand links. And so when we give it a DOI as a link, hopefully over here, we see that show up somewhere. Yeah, so that here followed that DOI, found the author, put it in as a citation. We can look right there at what it is, and we can follow directly to access that paper. Good stuff. Yeah. Then, so there's some like dollar math stuff that I wanted to show. Maybe over here. So these equations, these are just dollar math, which I think is sort of standard in Jupyter. But we have equation numbers here. And just to sort of help authors is you can label your equations. So we can put in a label here that's just like my cool equation. And then we can reference that down here. And again, this is just another link. Since it's a relative link, we can put in, or it's a link from the paper, we can put in a little hash. Cool equation, I think I called it. Nice. And it knows that that's equation 2. So we can see that there. And then if we like change these around, so we move that one down, this one becomes equation 1, and this knows it's equation 1. So this is just, I don't know, it's like things to make authoring easier. You don't have to worry about numbering your equations. You don't have to worry about, as a reader, finding your equations. They're all nice and linked. Yeah. Cool. Then we can also save this and see. So all of this is also in the site as well. If we go to that page, I think it was this guy. You have your equations now, and your little link to those equations. It's the same deal. You get a similar experience over here as you do in JupyterLab. Yeah. Exports. Let's do some exports. So the exports are pretty easy to do with the MyST tools. You can just choose the page you want exported. So we're just going to export the top-level paper and add it as part of the metadata. See how this goes. So we'll do a PDF export. And let's just kill this for a sec, and we can MyST build, tell it to build PDFs. It'll go through, it'll find the one up there that you asked it to build. Okay, you get a little error thing here saying we're missing the required key front matter, or required front matter key date. So if that red text stresses you out, you can add a date to the front matter. But now this thing works, and I guess I'm not in. Yeah, so this is here in build, exports, paper. And so this was the paper that I just built. And so maybe we don't really like this, this template. We can pick a different template. And so I'm going to go back to my paper and say, well, I want a la preprint template. And then we can export again. And it'll get the alternative template. So it uses the same data, fetches a different template, fills it in, and it looks like this template is happy without date. So that was a good way to resolve that red text. So I'm happy because I have a nice template and no red text, which is the goal, I guess. Although it renders slower, so maybe that stresses someone out. Anyway, so now if we open this again, it is different. I guess we have to close it and let it know that it should open again. Is this different? It doesn't look different, does it? No, it's different. It's different. That's different. Yeah. Right? I think it's different. Cool. Good. So that, I don't know, that lets you get back to the paper that you want. Wrapping up towards the end, but getting to maybe some of the cool things. So maybe I should get on with this. So another nice thing we have in our notebooks. Okay, we really like this figure. We don't want to create an image out of this figure. We want to actually use this figure. So let's put a label on here. We can call this label my figure. Very cool. Great. And I guess we should run all of these so that it actually works. And then we will save the notebook. And now we have this label, my figure. So we want to go back to our paper here. If you look through these figures, they're all just images, PNGs that we saved. But we could say, well, I don't want to use a PNG. I just want to put this other thing at the bottom, down here. And so this figure is just my figure. And change this, my figure. And we've killed this, so we got to MyST start again to get our web server going. Nice. And now if we go to, so this is the notebook that the figure was originally in, hanging out down there. If we go to the original paper, scroll all the way to the bottom, we hopefully see, no, we don't see anything. Gotta save it, gotta save it. Maybe, is that what you're saying? Yeah, okay, it looked saved. Gotta refresh. Hey, look at that. Cool, so it's in there, it's hanging out at the side for some reason. I guess that's probably because we have some of this stuff here. Maybe we just get rid of this fancy class stuff that we don't quite understand, and we don't want to repeat the name, and then we save it again. And now it's doing kind of what I hoped, which is great. Look at that, so easy. Okay, yeah, Perfect. And so then something else that is pretty neat maybe is inline execution. So in here, in this notebook, I was just going through looking at the source stuff. We have this super cool thing here that just is like a code cell that's printing a string. And so this feels like, oh, we could do maybe a little better than that. So like if we, oh man, this is all fine. This is all fine. So we take this here, we put it in a markdown cell. But then we get rid of this print. We get rid of all this stuff. We say, okay, well, this is the thing we actually want to evaluate. We don't need Python format strings. We can put that in there. Oh, man, get rid of this stuff here. Okay, and then we can put this in a little eval role. And if we're lucky, so that's a little eval role. It's got the thing that we want to evaluate in there. Ooh, so this works the first time. We should actually go through and make sure all of this is executed. And, oh, look at that. Never closed. That's perfect. Look at that. Look at that. That's wonderful. That means it's actually evaluating. And now we have that number in there. So this is like, I don't know, I feel like that's like a crummy demo to get to a very cool thing of like now we don't have to hard code things into our paper. We can actually have interesting numbers in our paper that come directly from the computation. Nice. And then like you can go back to your site, and hopefully that is all here if we figure out which one it was in. Yeah, so there it is, just in context in your paper. Cool, and then I think the last thing that I want to do, which is really pushing the limits of a demo here, but it worked yesterday, so it guarantees it'll work today. So yeah, we have the like interactive compute inline in your paper is getting set up. So we can just turn on Phoebe, and we save that. Now hopefully we go to these, and we'll pick oh yeah, look, it's there. It's there. So we'll go to this nice guy here. This now has a little power button that wasn't there before, but you'll just have to trust me. And now we can turn that on and execute the code here. This is in our website, and it gives us now these interactive bits. And so this is like this being in our website. When I say that, I mean it's like this is what we want the publication to be. This is in our final publication, is we have this little button that you can push and run the code, and now we can start to play with these interactive things over here. And right now, this is just hitting the local kernel, but you can also do this with Jupyter Lite, and I don't know, I'm not going to talk about that anymore because there is a presentation 2:30 today that Steve is giving on Phoebe. So that's very, very good. Cool. This is just showing how to get started. MyST in Jupyter is just a pip install. MystTools.org is where you can get all the information you need to get started. And and we're CurveNote. We kind of build journals out of this. So this is pretty much done, but this is an actual journal that we have that actually does the stuff that we're talking about. And like looking at these, you have your little, this is all like the little things that we have GIFs of in the presentation. So it's cool that it's kind of real. Anyway, that's it.
All right. Thanks very much, Franklin. Does anybody have questions? I think we have time for maybe one or two before the next speaker. And if the next speakers want to come up, go for it. I think that's a question. I think he has a question. Yeah, go for it.
Thanks. It looks amazing.
Can you repeat the question?
How much decision making can you do about how available the code is? Can you hide the code entirely or make it completely visible? Or inaccessible? Or
I'm sorry, how can you, or how much customization do you have around what's visible with like the notebooks?
Like say you have a really petty collaborator that doesn't want any of his code to be available. Can you make the paper entirely hide entirely the code?
So the paper is it's like you can write a Markdown paper that links into Jupyter Notebooks, and you can have it you can just pick individual cells and just display the output if you want, and then you have to have the other notebook to execute it. and then put the output in the paper itself. But you can pick and choose what shows up in the paper. Does that
Wonderful.
make sense?
Thanks. Yeah.
Yeah, okay.
Hey, thanks for your demo. This is really cool. I think for scientists, this is really convincing. Like, I really want to use this tech. But how do you work on adoption on journals? How do you convince journals to use technology?
Yeah. Yeah, so I think the question is, yeah, how you convince journals to use this technology. And I don't know, I think you start with the small journals that are flexible and willing to do it. And there's some bigger journals who are also interested in, like AGU journals in particular, are interested in notebooks and making notebooks I guess like the momentum that notebooks have is really helping because scientists are working in notebooks, and so there's now push of like, well, I wrote this notebook, I want this notebook to be what I'm publishing, and so that's getting some publishers to get on board. And I mean, I think it's just like a slow thing. I don't know if there's, yeah, I didn't talk at all about the like paywalls and like other awful things that journals are facing. But I mean, I don't know. It just needs to become a movement, and more people need to be asking about it, and more people need to be not okay with papers, I think. I don't know. I don't know if that's a satisfactory answer. But.
Quite amazing demo indeed. How do MyST tools and JupyterBook interrelate?
The question is how MyST tools and Notebook interrelate.
JupyterBook.
JupyterBook. Oh, perfect. Yeah, so I think JupyterBook uses Sphinx and builds static sites. So some of the big differences are MyST is native JavaScript, and so it's easier to build extensions for VS Code and JupyterLab, I think. It also, MyST is really, a fundamental part of MyST is the like underlying structured data for your document, which I think JupyterBook kind of bypasses. It just takes the content and builds the website, and the stuff in between is passed over. Yeah, I think those are two things.
Thank you.
Yeah.
Okay. Thanks very much, Franklin.